Record. All right, let's get to it. So as people come in, let's not be distracted. Let's just act like they're not coming in, not to be rude, but just because we're focused and we want to just keep the lesson going. I want to get through this so that I can give you time to work on your worksheet. So again, I'm going to number these so it's really easy to get caught up as you have to come and go. So example number 1 is just a very basic, what we call a two-step equation. If you ask anyone who's ever taught algebra before to write a two-step equation, and immediately a picture comes to mind of something like this. So this is as classic and standard as it gets.
Don't you just subtract 8 from both sides?
You do, and you've got some history with this, so you kind of know already. You have, when you come to me for Algebra 1, I know that Mr. Manlove in pre-algebra or whoever at some point has taught you generally what the deal is. So the rule goes like this, and I'm not going to do this every time, but for this first, maybe a couple of examples, I'm going to highlight something for you. And I don't care if you do what I'm about to do, but I'm going to put a box around this. I like to call that the variable chunk. And what I need you to understand is that the 6 is attached to the x by times. You will not pry it off yet. I need you to understand that that yellow box is off limits. What we're going to do, our thinking needs to be, let's get the yellow box by itself first. And again, you probably already have this because of prior knowledge that you've acquired, that it's the 8 that has to go away first. So like Seth said a while ago, we are going to subtract 8 from both sides. Like that. And we can then say the mission has been accomplished because the stuff that was in the yellow box has been isolated, which is exactly the mission. So we get 6x equals, and then we have negative 10 minus 8, which is negative 18. So what happens today is we find ourselves doing one thing, and it leads us to a problem that looks like what we've been doing before. So now we just have a standard one-step equation. How are we going to get rid of that 6? We're going to divide both sides by 6, just like that. And we're going to drop down the x, and we're going to drop down the equals. And negative 18 divided by 6 is negative 3. And then you're going to box it up, and that is example number 1. That's as classic and basically simple of a two-step equation as I could possibly think of. All right. I didn't call today's lesson two-step equations because there's at least going to be 1 or 2 or 3 in your assignment that really technically could arguably be 3-step equations. So that's why I just decided let's just start calling them multi-step, because from this point on, multi-step can mean 2 steps, 3 steps, 4 steps. We're going to have equations that might take 6 steps. So that's example number 1. Do you have any questions there? Okay. Number 2 is m over negative 2 minus 4 equals negative 11. And I'll do it again.
Please excuse the interruption. We need 9th grade students with the last name M through Z to the comments for pictures.
Before you leave, remember what I said. If you're leaving, just go watch the video and watch the examples that you're going to miss, okay? You'll be able to keep track of it. There will be 5 examples in today's notes, so you'll know which ones you need to go back and rewatch. So this is example number 2. And again, what I did is I took the variable chunk and I put it in a box. One of the big mistakes people like to make is they get rid of the negative 2 too soon. And again, the yellow box should not be what you're messing with. The yellow box should be just, you stay, sit. I'm going to go clear away that dumb 4. And how are we going to get rid of that particular 4?
Add 4 to both sides.
Absolutely. So we're going to add 4 to both sides like this. And then we're going to cross these off, and then we're going to bring straight down-ish the variable chunk. And then, as always, I assume you can do the basics. What's negative 11 plus 4? Negative 7. And you find yourself, again, now realizing that the end of every problem we now do will look like what you just took a quiz over.
But you just add, don't you just add 7 to both sides? Or no, you add 2 to both sides.
We want to get rid of this negative 2, but it's currently a division, so we do multiplication by negative 2.
That's where I messed up.
And I'll be visiting with a couple of you But I really need you embracing the idea of using parentheses. I need you to stop putting like time signs and putting your multiplications underneath and stuff. And that's not me trying to control your behaviors. I don't have time for that. It's going to help us all, you especially in the end, if you start parenthesizing equations when you want to multiply. I hope you trust me. I mean, I hope you come to trust me enough to know that I'm not going to ask you to do stuff if it doesn't have a reason.
So we just correct even.
That's all we're doing today is taking notes. Yes. So we just completed example 1, and now we're on example 2, and then we're going to do 5 of them, and then we're going to do a homework assignment. So yes, I know you just came in. We're just taking notes today, and then we're going to start work. So again, step 1 was to get rid of the straggler. The plus or minus term should always get moved away first. The second step in this case is then to get rid of the -2. Anytime you eliminate somebody, you have to know who he is. It's never going to change. If he's a plus, you use a minus. If he's a divide, you use a times. Like that's always going to be Algebra 101. These are going to cancel out. We're going to bring our m straight down, our equals straight down. And what is a -7 times the -2?
14.
All day long, +14, box it up. And the offer stands all year. If you want to check your solutions, you're wise. I just gave up on telling kids they had to do it like 20 years ago. I mean, I feel like if you want to know if it's right, plug it back in and do the math and see if it equals -11. So, all right, 2 down, 3 to go. Number 3 is -5 plus x all over 3 equals -2. This is a very unique problem.
It's new.
It's different in that if you're paying attention to the lesson, you might feel like you want to get rid of the -5, but you can't. And the problem is that the -5 is currently like locked up in jail on the top. Does anyone instinctively just know what we should do first?
Add 2 to the 3. And
No.
the
Times by,
You-
times by name.
You had it right the
-2.
first time, Rowdy. Our objective is this. First off, look at this thing right here. It's called a fraction, right? And I say to myself, like, this would not be a hard problem if that stupid 3 weren't there. Like, if that weren't even a fraction, I could just go on my way and then move the 5 and be done with it. So a big thing in Algebra 1 is how do I make fractions not be fractions? And the answer is always kill them. I mean, I don't mean to be violent or anything. I'm just saying fraction killing is a big part of what we do in room 135. You're going to put parentheses on this whole equation and you're going to multiply by 3. You're going to not touch the -5 and the plus x. That is like the chunk that's going to just fall down. What's happening is when you do the 3 like this, have you ever seen those people who like pull a tablecloth out and then all the dishes and glasses just sit there? I don't know if you know what I'm talking about, but like people yank the tablecloth and then all this. That's how I feel about what I'm doing right now. I feel like I'm pulling the 3 out and then the -5 and the plus x are just going to drop down. So here it goes. When you multiply by 3, those die. The -5 and the plus x just fall onto the tabletop. And the equals comes down. And then what's -2 times 3? And for the third straight time now, I hope you agree, we have just created a problem that looks like what is on the quiz that you just got back. So old skills becoming useful for new skills. And now to get x officially by itself, what would we do?
Add 5.
We would add 5 to both sides. Like this. And we get x equals -1 all day long.
We go back to question number 1.
I can.
Stop it.
Yeah. If any of you guys came in late, if you'd like to take 30 seconds and copy it down, it's no problem. I made number 1 on purpose as the most straightforward 2-step equation I could think of. Example 4, I'll just warn you, is actually one that gets missed all the time, but it looks so easy. And so you've been warned. It's not hard, just pay attention. The kind of walkthrough on problem 1 for those of you that came in late is we subtracted 8 first to get the box by itself, and then we divided by 6, like basic. All right, I'm going to drop down now. Example number 4. 4 looks so innocent and fluffy. But in I have the benefit of having so many years of doing this that I've got a very acute awareness of what teenagers' primary mistakes are in algebra. I didn't
We need to follow.
I didn't know that stuff a long time ago, but now I do.
Pesky, Stephen Rutledge, Riley Smith, Violet Williams, and Kellen Winslow.
The primary mistake people make on this problem is that they add 3 to both sides. And it's because there's a minus and there's a 3. The trouble is that minus does not belong to the 3, correct? So our target should be the 3. And you might say, this doesn't look like a 2-step equation. It is. And so to get rid of that 3, what do? You do. And it feels so almost unnatural because of the minus. But remember, the minus is the property of the y. So when you eliminate a 3, a positive 3, you need to subtract 3 like this. So you got to tell yourself, do I want to learn that correctly? And I hope the answer is yes. Don't fall for the minus. Ask yourself, to whom does it belong? And then move on accordingly. So the 3s are going to die. And now what I'm going to do is I'm going to drop everything down. On this right side, I'm not bringing down y. I'm bringing down negative y. Is the problem done?
How'd you get 9? Oh,
12 minus 3. The problem is not done. And the reason is because there's a number in front of y, right? You always ask yourself, is the variable by itself?
No, because a variable can never be a negative variable. Like it can never be a negative y as your equals something.
Right, like it can be. We're just not done, right? We got to fix it. What number is right where I'm pointing with that arrow? -1, exactly. And so if it helps you while you're learning algebra, I've got no issues if you put a 1 where there is a 1. I wouldn't usually put a positive 1 because that's just kind of weird. But with negatives, I think it'll help you as you're kind of getting over the initial hump to put a 1 next to a negative. And then it'll remind you, this isn't anything spectacularly new. All I have to do now is quite literally divide both sides by -1. Bring down your now perfect done positive y, bring down your equal sign, and then do the math. What is 9 divided by -1? And we are done. I'm telling you right now that despite the fact that that looks initially like a pretty easy problem, that's an example of a very quiet dog with a very large bite. Okay? Some problems, like what I was doing in Algebra 2 this morning, factoring differences in sums of cubes, is the opposite. It has a really big bark, but it has a tiny little wimpy bite. This problem feels like the backwards. It looks crazy easy, but it's a little bit maybe trickier than we think. So watch out for those. When there's a minus in front of the variable, step up your game. Last one. And by the way, there's going to come a day, months from now, when we go back and we see problems like this, and we do it in a much different way. We're just not really at that point yet. So that problem can be done differently. I just don't want to bombard you with options. Like, I want you just, hitting them. The same can be said of question number 5. So
We're only doing 5 of these, right?
5, we're done after this one, and then you can have your worksheet and get crack-a-lacking on it, okay?
Okay.
I am going to do this problem with you twice.
Like,
Not because I'm like having a stroke or losing my mind or something. I'm going to do it with you twice because I want you to see the multiple options that you have. This time I am going to give you some options.
do we have to write them both, or can we just?
I would write them both unless your brain tells you that, like, if the first one I do you love, then you can ignore the second one.
I'm just gonna write.
I'm going to show you the way to do it first, just like I did with the crisscross ones on the last quiz. I'm going to show you the way first that always works. Always. So here it goes. You've heard of the word distribute before, right?
Yes.
And so what I'm going to do is I'm going to say parentheses, no. So I'm going to take -4 and I'm going to multiply it by that. And then I'm going to take -4 and I'm going to multiply it by that. I know that someone before you met me has asked you to distribute. So having said that, what is the answer to the red problem? -4 times 2 is -8. Negative times a positive is a negative. 4 times 2 is 8. Done. What is the answer to the yellow problem? It's not -4x. It's a positive 4x because that's a negative 4 being multiplied by a negative x, which changes it to plus 4x. Color-coded for your educational convenience, right? And what happens now is by distributing, you have now created an equation that's virtually identical to the first example we did 15 minutes ago. Very standard textbook two-step equation. The variable chunk is the 4x. You leave that alone. Who are you going to get rid of first?
Add 8 to both sides.
We're going to add 8 to both sides like this. We're going to cancel those out, and we're going to bring down a 4x and an equal sign. And what's 16 plus 8? 24. And then we're going to divide both sides by 4. So this is our first time together doing a three-step equation, I think. So we're going to divide by 4, and what does x equal? Good. I'm telling you this because I can tell that you're listening, and I appreciate you for that. That method always works. I don't take that word lightly. 100% always works. However, now I'm going to show you another option that sometimes works, and it's a little bit quicker when it does. So here's my observation. I say to myself, I don't like those parentheses. The way I got rid of them on the left side was I distributed them away. The way I'm going to get rid of them on the right side is actually a little more clever. You ready for this? I'm going to divide both sides of this problem by -4, which is actually pretty slick because on the left side, these -4s take a dirt nap and the parentheses melt away. The parentheses were only needed because of the dumb -4, right? And if I can eliminate the -4, then the parentheses just fall away. And I'm left with 2 minus x equals -4. Do you see what I did?
Yeah, you just made that a heck of a lot simpler.
I think maybe simpler. You might say six of one, half dozen the other. At this point, what I'd like to say about it is you choose. Now, can you think of a time? I'm not going to finish this, by the way. I don't think we need to. Like, you're going to get the same answer. But the question I have for you is this. Can you think of a time when this purple box method won't work? That's a big brain question. Come on now.
If there's
Go ahead. Interesting. Not what maybe that would be weird. That would turn into more of like a rational potential. That's good answer, but not what I was looking for. I could just change a number in this problem to make the purple box method no longer viable or practical.
-4.
Yeah.
16 or 17.
Yes. This method working is predicated on the idea that these two numbers in the green box divide evenly by each other, right? I don't know about you, but I would not want to have done that method if the problem said something like this. If it said -4 times blah, 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 like, I don't know, x plus 6 or something equals 17. I don't know about you, but I don't like fractions. I can work with them, but I don't like them. And so if I were to try that purple box method and then I divide both sides by -4, I have kind of an oh crap moment because the -4s cancel and I get x plus 6 and I'm feeling really good. And then I go, poo, 17 doesn't divide evenly by 4. So my advice to you generally is to really, 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 really embrace the method on the left because it will always be your friend. Okay? And that way there in the yellow box, if you get a fraction, you're not going to see it until the very last step when you don't care anyways, because it'll be your answer. Got it? Yeah, man.
I don't know how, but I got x equals 5 on second.
You want me to finish the second method? Yeah, I was wondering if that was going to come up. Let me actually make it official and finish it. I should have done that anyways. That was stupid. So what we got was 2 minus x equals 16, right?
Yeah.
And this, remember, is one with a big bite and a little bark. It looks so innocent, and you're like, oh, cute little doggy. And then you go to pet it and it bites your thumb off, right? What do we do first? Subtract that +2 from both sides, right? Do you see it? Oh, I forgot. I shouldn't have put 16 there. What a ding dong. I should have put -4. What a slacker. I apologize. So if we subtract 2 from both sides, we bring down the -x. And what's -4 minus 2?
Graders, last name A to L to the commons for fiction.
-4 minus 2. What's that equal? -6. And then what do we have to divide by? -1, which gives us, lo and behold, the same answer. X equals 6. Moral of the story, you're going to get the same answer. You got to find the method that kind of you vibe with, so to speak, right? All right. I guess I'll leave the recording going, but I'm going to hand out today's worksheet. My plan originally, I'll leave the recording going, so if anyone's watching this, they'll hear me say this. My plan was to have you do this today. I was not aware that picture day was today and that my hour would be sort of wrecked by the chaos. So I'm going to have you work really hard for 7 minutes, and then you can put it away. All right. And you can not work on it for the next 23 hours, and we will resume our work tomorrow. Got it? Everybody hear that? All right.